Peterson capture-recapture is a type of sampling that we can use to estimate the size of a population when you can't just count it. So if you had a woodland, say the black box represents a woodland and the purple circles within it represent birds in a woodland, a specific type of bird, I don't know, let's say a blue tit. Okay. Now, we want to carry out an investigation to estimate the number of blue tits in this woodland. We are unable to stand and count all of the blue tits because it would be physically impossible because the birds are moving and all the rest of it. So we would use something called Peterson recapture to work out an estimate of the size of the population of blue tits. Okay, and this is how it works. So your first step is to capture some of the population. So imagine this is you here. You would capture some of the population. So say you managed to get that much of the population. Okay. What you do then is you take that part of the population and you put a tag on the individuals. Okay. So you're putting in an individual tag on those 5 that you've managed to collect. And you would then set those birds free again. So those birds would go and move and change themselves and go back into the population. Okay, so I'm just going to show that. So these 5 birds, the line is going to disappear, look, because you're now freeing them and they're able to go and fly away and spread out into the population. So you'd maybe give it a day or 2 and those birds would all spread themselves out evenly within the population. So that one might take itself there. This one might take itself there. That one, these birds are, remember, all moving. So they'll have separated themselves into that population. They'll be dispersed. Okay. Right. The next thing you do is this. You then capture a part of the population again. Okay. So you've given it a few days. You then capture some more of the population. Okay. You might capture this and you notice that 1 out of 5 of your captures, the recaptures, because you're recapturing them, have a tag on them. You can then use that to estimate the size of the population. If 1 of your 5 of your recapture, if a 5th of your recapture have a tag, 1/5 have a tag, you can estimate that of the original 5 you collected, right, that is 1/5 of the population. So 1 out of 5 is equal to 5 over 25. So you could say, well, the population size, we call it N, is around about 25. Now, I'm going to go through that calculation a bit slower on a proper question, but that's the whole idea of it. You capture, tag, release, recapture. So capture, tag or mark in some way, release, and recapture. And the whole idea is that your proportion of your original capture is the same proportion compared to the total population is in the same proportion as your recapture with the sample size that you've recaptured. So here we go. Here's a question, a typical capture-recapture question. Beth wants to estimate, it's always an estimate because you're never going to know exact numbers. Okay, it's always an estimate. The number of frogs in a lake. She captures a sample of 80 frogs, marks them and puts them back in the lake. Okay, so her initial capture is 80 frogs. That's her initial sample. Later that day, in a second sample of 80 frogs, she finds that 10 of them are marked. Right. So this is kind of the formula that you would use. You can do this logically, but let's think about what this is going to be. So it's your sample size, so your initial sample size collected, divided by your total population. They often give the value n, the letter n to the total population, is equal to your tagged in your recaptured. So when you collect your second capture in over the sample. Okay, over your sample recaptured second sample. Let's call that second sample. Okay, right. So she captures a sample of 80 frogs. That's your first capture. And this is your second capture. We need to keep it in the same proportion. So she captures a sample of 80 frogs, marks them, puts them back in the lake. We don't know the total population. That's what we're trying to work out, the total population. And that is equal to the second sample, 80 frogs collected, 10 of them are marked. So 10 are marked out of 80. So we can assume that when she initially collected those 80, that's an eighth of the population. You're keeping these in the same proportion, the same ratios. Two ways of kind of doing this. We can think, well, 10 has been times by 8 to get to 80. We need to do 8 times 8 to get to 640. Okay, and 640 would be the estimate for the number of frogs in the lake. Or we can do this using algebra. So 80, or just rearranging, 80 over n equals 10 over 80. So if we multiplied both sides by the n, we end up with 80 equals 10 over 80 times by n. So n is going to be 80 divided by 10 over 80. So 80 divided by 10 over 80, or an eighth. Remember, this is all calculator, isn't it? Is equal to n. And you'd get the same answer there of 640. I'll just show you. 80 divided by an eighth, or 10 over 80, is equal to 640. Okay. Right, another question for you to try. Actually, let's cover assumptions first. So assumptions that you have made. Now, these are very similar for all the questions, but once again, link them back to the question and think, well, how's it going to make sense? The first one, these are the general assumptions, and then we're going to link it to the question. The first one to consider is time, okay? Has the person carrying out the investigation left enough time for them to mix, but not enough time for the population to change? By population to change, that means births or deaths. So long enough for the population to mix, but not too long as we do not want population changes. We do not want births or deaths. Do not want changes in the number of population, because that will obviously affect the results. Okay, so we're talking births and deaths there. The second thing to consider is the tag, okay? Could it easily come off? Could it easily wash off? And also, does it make it more susceptible to be got by a predator? So if you put a fluorescent tag on a type of animal that's going to try and hide in order to make sure it's not being eaten by the predator, then therefore it's going to increase the chances of it being eaten, and that's going to affect our results, isn't it? Because there's going to be less of them with the tag. So could it easily wash off or come off? That's the first thing to consider. And the second thing is, does it put it at a disadvantage or an advantage for survival or population change? Okay, so those are a couple of things really to consider. So assumptions, we have made an assumption. If we are using this maths, we're making the assumption that that the population has mixed, okay, that we've had enough time for the population to mix, and also that the tag doesn't wash off, okay, the mark in this case, that the mark hasn't washed off. Because if the marks have washed off, then in your recapture, how can we be sure that it's 10 of them were originally marked? Maybe it was 12, but 2 marks washed off, okay? So you just need to be careful of those. So let's just complete that question. We've made the assumption that the marks have not worn off, and that the frogs have had enough time to disperse. Okay, make sure you get those notes down, the bits that I've written that you need for your notes, okay? Right, another question. Feel free to pause it and give it a go before you listen to my explanation. So let's look at the key numbers we need here. She's caught a sample of 70 birds. That's going to be our initial capture. And she's tagged each of these birds. Now we are going to write N because that's our population we're trying to work out. The next day she captures a sample of 60 birds. So our bottom number is 60. That's the recapture sample size, the second sample size. And she's tagged 12 of those birds. 12 of them are tagged. Work out an estimate for the number of birds in the sanctuary. Okay, so you're either thinking, well, 12, what has 12 been multiplied by to get to 70? And you could figure that out by doing 70 divided by 12. Or we can rearrange it. So I'm going to rearrange it. We're going to do 70 is equal to 12 over 60 multiplied by n. So therefore 70 divided by 12 over 60 is equal to n, and you can put that straight into your calculator. Okay, so just to be clear on the steps we followed, we've multiplied both sides by n, and then I'm dividing both sides by 12/60. Okay, that's just rearranging formula like you would in maths. Right, let's put that into our calculators. So we're doing 70 divided by 12 over 60, giving us 350. Okay, so the total population size was 350. Right, write down an assumption. It only wants one assumption. Let's have a look. So we're thinking about time. We're also thinking about the tags. Okay, Riverina wants to make an estimate. She catches and tags each of these birds. These birds are then released back. And so an assumption could be that the tags did not fall off the birds. Okay. But you could say that the birds had had enough time to mix again. You could also say that the tags didn't give a disadvantage to the birds. For example, it was so heavy that the birds couldn't fly and they were weighed down, so therefore they were more likely to be recaptured. You know, lots of different things that you can kind of think about. And the beauty of stats is as long as it makes sense, then it will be accepted. It doesn't have to be on a mark scheme. We could have a, you know, or equivalent, something that you've kind of thought about. Okay, so that's all there is to Peterson capture recapture. I hope that's helped.